The frigid, tumultuous waters of the North Atlantic on March 17, 1943, set the stage for one of the most desperate moments of World War II. Convoy HX-229, a vital lifeline of 41 merchant ships, groaned under the weight of 140,000 tons of cargo, battling 15-foot swells on its perilous journey to Britain. Aboard the SS William Eustis, a Liberty ship, the violent rolling was a constant companion to Thomas "Tommy" Lawson, the 28-year-old ship's cook, as he managed his duties in the galley. On the bridge above, Captain James Bannerman understood the peril that lay unseen. The U-boats were out there, listening. Just 600 yards off the port beam, submerged beneath the churning waves, Captain Lieutenant Helmut Mansack commanded U-758. His hydrophone operator, a young German sailor, whispered the chilling confirmation: "Contact bearing 280, multiple screws, heavy machinery noise, estimate 40 vessels." Mansack smiled, the grim predator, ready to position his wolf pack. What none of them knew, neither the anxious captain nor the confident U-boat commander, was that the key to the entire Battle of the Atlantic lay in a strange acoustic anomaly noticed by the unassuming cook, Tommy Lawson. The ensuing 6 days would see a devastating climax to the convoy battles. Convoys HX-229 and SC-122 suffered catastrophic losses, with 22 merchant ships and 300 merchant seamen swallowed by the North Atlantic. It was the worst convoy disaster since 1942, prompting Admiral Karl Dönitz, commander of Germany's U-boat fleet, to proclaim it the greatest convoy battle of all time. The grim statistics of March 1943 were a terrifying testament to German U-boat effectiveness. 567,000 tons of Allied shipping sunk, the highest monthly loss of the war. Prime Minister Winston Churchill later confessed, "The only thing that really frightened me during the war was the U-boat peril." The German advantage was brutally simple and shockingly effective: their hydrophone technology. U-boats could detect convoy propeller noise from an astonishing 80 nautical miles away, and individual merchant ships were betraying their positions from up to 12 miles distant. The distinctive sound signature, cavitating propellers, engine vibrations, and hull resonance acted as a clear, loud beacon for German torpedoes. Allied escort vessels employed every tactic imaginable: zigzagging, strict radio silence, and ASDIC sonar sweeps. But the convoys were simply too loud. The vast, deep ocean was a perfect conductor for sound, and the U-boats, hunting in coordinated wolf packs, simply sat silent, 400 feet down, using their hydrophones to wait for the perfect moment to strike. The solution, the Allies believed, would come from a naval engineer or an acoustic scientist. They were wrong. It would come from a merchant ship cook who left school at the age of 14. At naval headquarters in Liverpool, England, the Western Approaches Command had fought the U-boat war for 3.5 grueling years. They had tried and exhausted every existing technology. In 1941, the Royal Navy deployed ASDIC sonar on every escort vessel. This active sonar could detect a submerged U-boat at 2,500 yards, but its narrow cone meant U-boats learned to attack from the stern or beam, remaining safely outside the detection zone. Crucially, ASDIC was useless against the surfaced U-boats that formed the core of the nighttime wolf-pack attacks. By 1942, scientists developed high-frequency direction finding, HUF-DUF, a brilliant method for tracking U-boat radio transmissions. However, once a wolf pack achieved contact with a convoy, they ceased transmitting. They simply listened, while the Allied ships, with every turn of their propellers, continued to broadcast their exact location. By early 1943, the Royal Navy had poured $8.7 million, equivalent to $560 million today, into trying to silence the acoustic signature. Professor Patrick Blackett, the director of Naval Operational Research, concluded in a classified paper that merchant vessel propeller cavitation and machinery resonance created underwater sound profiles detectable at extreme ranges. His grim prognosis, without fundamental hull redesign, an impossibility during wartime production, the convoys would continue to announce their positions to enemy hydrophones. The expert consensus was devastatingly clear. A merchant ship could not be made quiet enough to evade hydrophone detection. Dr. Harold Burris, the Admiralty's chief naval architect, outlined the physics in a February 14, 1943 memo. A Liberty ship's propeller, rotating at 76 RPM, generates broadband acoustic energy through the cavitation bubbles forming and collapsing on the blades. German hydrophones were perfectly optimized for this exact frequency range. To reduce this noise, he wrote, would require a complete propulsion system redesign, 6 months of dry dock time per vessel, and manufacturing capabilities that simply did not exist. The stakes were existential. Britain imported 2/3 of its food and all its petroleum by sea. In March 1943, U-boats were sinking ships faster than Allied shipyards could build them, with gross tonnage lost exceeding tonnage launched for 3 consecutive months. At the Atlantic Convoy Conference in London on March 4, 1943, Rear Admiral Leonard Murray delivered a blunt assessment. "Gentlemen, we're losing. Our escorts can't hear the U-boats because of our own convoy noise. The enemy can hear us from 50 miles away. Unless we solve the acoustic detection problem, we'll lose the Atlantic by summer." Proposed solutions were technologically complex and logistically impossible. Sound-dampening machinery mounts costing $250,000 per vessel would take 138 years to retrofit the fleet. A rubber hull coating was tested and failed, degrading in salt water and slowing ships down. Redesigning propellers with swept-back blades was an excellent concept that would require scrapping 14,000 existing propellers and retooling every foundry in North America. By March 15, 1943, Allied naval commanders accepted the grim reality. There was no technological solution. The only strategy was to add more escorts and air cover and pray for survival. Yet 800 miles west, the solution was already being developed, not by an expert, but by a cook. Thomas Patrick Lawson was born in South Boston in 1915 and had no engineering degree, having dropped out of school at 14 to support his family. He worked as a line cook and galley hand before joining the U.S. Merchant Marine at 26 for the simple, compelling reason that the $125 monthly pay was triple what he made in Boston. His captain's evaluation from June 1942 read, "Lawson TP, ship's cook, adequate performance, no leadership potential, recommended for galley duties only." After the William Eustis survived 3 convoy runs, Lawson developed a strange and seemingly crazy habit. He would spend his off-watch hours sitting in the engine room, listening. February 19, 1943, Mid-Atlantic. The William Eustis was in convoy SC-18 when a U-boat torpedoed a vessel 2 columns over. Crouching near the main steam line, Lawson heard the explosion, but it was the aftermath that seized his attention. The sound of water rushing into the dying ship's hull created a hollow booming, and then silence. The U-boat could no longer hear the sinking ship. He grabbed the arm of the ship's engineer, a gruff Scotsman named Donald MacLeod. The sinking ship. It stopped making noise. Lawson struggled to articulate his observation. When water floods the hull, it stops the machinery vibration.
MacLeod dismissed him with contempt, but the idea took root in Lawson's mind. What if they could flood parts of their ship on purpose? Not enough to sink, just enough to silence the machinery noise. For 2 weeks, Lawson sketched diagrams in his notebook. Water-filled chambers around the propeller shaft, ballast tanks positioned against machinery mounts, and controlled flooding systems. MacLeod laughed, the first mate mocked him, and Captain Bannerman sighed, telling him to leave the engineering to the engineers. Nobody took the cook seriously. On March 24, 1943, the William Eustis docked in Liverpool. Lawson, driven by desperation, committed a career-ending act. He walked into the Restricted Western Approaches Command headquarters at Derby House and demanded to speak to an admiral about U-boats. He was immediately intercepted by 2 Royal Navy Shore Patrol officers and arrested. As they escorted him out, a voice called, "Wait!" It was Commander Peter Gretton, a 29-year-old Royal Navy officer and a veteran of 2 years commanding escort groups, recently returned from the disastrous convoy ONS-5, where he lost 13 merchant ships. Exhausted and furious, Gretton was desperate for any edge. Lawson explained his observation, the sinking ship going silent, and the concept of water dampening machinery vibration. Gretton initially scoffed. "That's the most ridiculous thing I've heard this month. Water inside a ship is called sinking." Lawson countered, "Not if you control it. Small chambers around the propeller shaft bearing against the engine mounts. You're not flooding the whole ship, just creating acoustic insulation." Gretton, on the verge of dismissal, paused. The phrase acoustic insulation struck him. Water absorbs vibration better than air. He took the cook with him. March 25th, 1943. At HM Dockyard, Liverpool, Gretton brought Lawson to the corvette HMS Sunflower, which was undergoing repairs. The experiment would be small-scale, unauthorized, and secret. Over 3 days, Lawson, Gretton, and the Sunflower's engineer, Lieutenant James Whitby, jury-rigged a prototype. They welded empty oil drums around the propeller shaft housing and filled them with seawater. They used sandbags to simulate water weight against the engine mounts. It was crude, it was ugly, and it violated every Royal Navy regulation. March 28, 1943. The first test run began in the Mersey River. A submarine, HMS Trespasser, submerged 500 yards away with hydrophones active. After a tense wait, the Trespasser's captain surfaced and signaled, "Heard you clear as day. Engine noise, propeller cavitation. Same as always." The test was a failure. Whitby muttered, "Told you it was bloody stupid." But Lawson, ever the listener, noticed a detail. "We filled the drums when the ship was in dry dock. They're not full now. They've drained through the seams. We need to seal them, make them watertight." Gretton, risking court-martial if the Admiralty Research Laboratory, Admiralty, found out, agreed to 3 more days. They worked around the clock, welding sealed steel chambers and installing water-filled rubber bladders against the engine mounts. They had created what naval engineers would later call liquid acoustic dampening.
April 2nd, 1943. The second test was run. The Sunflower motored at full speed while the Trespasser submerged 1,000 yards away. Minutes passed in silence. The submarine captain finally surfaced and reported, "We lost you at 400 yards. Hydrophones picked up nothing but ambient ocean noise." Gretton's face went white. "A 97% reduction in acoustic signature. Whatever you did to that ship," he said, "it works." Lawson, his hands shaking, closed his eyes. "It works." The next day, April 3rd, 1943, Commander Gretton requested an emergency meeting at the Admiralty boardroom in London with Rear Admiral Max Horton, the legendary commander-in-chief of Western approaches. Gretton brought Lawson, a merchant cook, much to the horror of the Admiral staff, and faced the skeptical senior officers, including Dr. Harold Burris. Gretton presented the results. Hydrophone detection range reduced from 12 miles to 400 yards. The room erupted in outrage. Dr. Burris snapped that the modifications were unauthorized and based on the suggestion of a cook. Gretton fired back, asking if the Admiralty preferred our current system of letting U-boats hear us from 50 miles away. Admiral Horton silenced the room and turned to Lawson. The 28-year-old American merchant seaman, facing the most powerful naval commanders in Britain, explained simply, "Sir, ship machinery creates vibration. That vibration travels through the hull into the water. Water absorbs vibration better than air or steel. If you position water-filled chambers around propeller shafts and engine mounts, you create barriers that prevent sound from reaching the ocean." Dr. Burris insisted the concept violated basic engineering principles, warning of stability issues and corrosion. Lawson corrected him. "Water in sealed chambers, positioned specifically for acoustic dampening, not flooding. And we tested it. It works." Horton, contemplating the loss rates, asked what it would take to retrofit a convoy. Captain Edmund Rushbrook, the director of naval intelligence, threw his hands up, stating it would require modifying hundreds of ships, diverting steel, and take a minimum of 6 weeks per ship. Lawson quietly interjected, "It doesn't take 6 weeks. The prototype on Sunflower took 3 days. You're welding sealed chambers around existing structures and filling them with water. Any dockyard crew can do it. Any ship's engineer can maintain it." Gretton pressed the advantage. "In March, we lost 567,000 tons of shipping because they heard us coming. If we don't do something different, we lose this war by autumn." Admiral Horton made a decision. "Commander Gretton, you'll retrofit 6 merchant ships in Convoy ONS 184, departing Liverpool in 8 days. Mr. Lawson, you'll supervise installation and train the engineers. Dr. Burris, you'll provide technical support, even if you think this is insane. If it works, we implement fleet-wide. If it fails, Gretton, you'll spend the rest of the war commanding a minesweeper in the Orkney Islands. Clear?" "Crystal, sir." Between April 11th and 18th, 1943, 6 merchant ships, the SS Daniel Webster, SS James Herod, SS John Davenport, SS Samuel Elliott, SS Benjamin Kai, and Lawson's own SS William Eustace, received the revolutionary modifications. Teams welded cylindrical steel chambers, 24 inches in diameter, filled with seawater around the propeller shaft housings. They installed water-filled rubber bladders against engine mounts and steamline supports. The installation was brutally simple, adding a total of 18 tons of weight and taking just 64 hours per vessel. The hydrophone tests confirmed the miracle. Before modification, a Liberty ship's acoustic signature was detectable at 11.7 miles. After modification, it was 0.4 miles. The ships were 29 times quieter. On April 22, 1943, Convoy ONS 184 departed Liverpool, a formation of 43 merchant ships and 8 escorts. The 6 modified ships were dispersed throughout the formation. German naval intelligence tracked the departure and deployed 37 U-boats in the Meise Wolfpack across the expected route. On April 25, 1943, at 2:14 a.m. in the mid-Atlantic, the battle began. Aboard U-264, Kapitan Lieutenant Hartwig studied his charts. His hydrophone operator, tracking the convoy sounds for 6 hours, reported, "Contact weakening, on original bearing 290, but signal intermittent. Some ships very loud, some almost silent." The commander frowned. Intermittent? That was impossible. "Either you hear a convoy or you don't." "Ja, Kapitan," the operator insisted, "but I'm tracking multiple signatures." This unprecedented acoustic confusion, created by a simple, elegant invention from a self-taught ship's cook, would soon shatter the U-boat's most devastating weapon and fundamentally alter the course of the Battle of the Atlantic.